Welcome. Tonight, we begin a journey into the heart of our galaxy to meet one of the most extraordinary objects in the known universe, the supermassive black hole called Sagittarius A*. It rests at the very center of the Milky Way. From our home here on Earth, it lies more than 26,000 light-years away. That number may feel too large to hold in the mind. A light-year is the distance light travels in 1 year, moving at nearly 300,000 kilometers every second. In just 1 second, a beam of light could circle Earth more than 7 times. And yet, even at that unimaginable speed, it takes 26,000 years for light to reach us from Sagittarius A*. When we observe it, we are not seeing it as it is today. We are looking far into the past, across the abyss of time. The black hole we speak of tonight is already ancient in the image we see, older still in reality. Sagittarius A is massive beyond comprehension. It contains the mass of about 4 million suns. Picture our sun. Its sheer size dominates the solar system. Everything that lives and breathes on Earth depends on its light. Now multiply that star by millions and compress all that weight, all that gravity into one dark and hidden point. That is Sagittarius A*. Its event horizon, the boundary beyond which nothing can escape, spans roughly 12 million kilometers across. To compare, Earth is about 12,000 kilometers wide. This means the black hole's edge is nearly 1,000 times larger than the entire Earth. If we were to place Sagittarius A where our Sun is, the boundary of the black hole would extend far beyond Mercury's orbit, reaching almost to Venus. The solar system would look very different indeed. And yet, compared to the galaxy it anchors, Sagittarius A is small. The Milky Way is vast, stretching 100,000 light-years from edge to edge, containing hundreds of billions of stars. Against such immensity, even a supermassive black hole is just one point at the center, holding everything together with its quiet, irresistible gravity. But what does it mean to speak of something so enormous, so distant? To understand, let us begin with scale. Think of Earth. Our world is a sphere of oceans, mountains, and sky. If you set out to walk around it without pause, you would cover about 40,000 kilometers. That seems vast when we travel from city to city, but it is tiny compared to the Sun. The Sun's diameter is 100 times greater than Earth's. More than 1 million Earths could fit inside the Sun. Now step outward again. Imagine the solar system. The orbit of Neptune, the outermost planet, stretches almost 5 billion kilometers from the Sun. A journey to Neptune at the speed of a modern spacecraft would take more than a decade. Yet even this vast system of planets is a mere pinprick in the Milky Way. From one edge of the Milky Way to the other is 100,000 light-years. Our solar system is tucked away in a spiral arm, far from the center, like a small village on the outskirts of a great city. At the center of this city lies Sagittarius A, heavy enough to keep the stars of the Milky Way in their slow and graceful dance. When we speak of 4 million suns, worth of mass, it is not easy to imagine. Numbers this large slip away from ordinary thought. But we can approach the feeling of it through comparison. If Earth were reduced to a grain of sand, the Sun would be a sphere about the size of a beach ball. And Sagittarius A, it would weigh as much as a mountain made entirely of sand, rising above all sight, too large to climb, too heavy to measure. The black hole is invisible, hidden behind a veil of dust and gas that fills the galaxy. But we know it is there because we can see its influence. Stars near the galactic center whip around it at tremendous speeds. One of them, known as S2, completes an orbit around Sagittarius A every 16 years. To circle a black hole 4 million times the mass of the Sun in just 16 years, that star must travel at thousands of kilometers every second. Only a black hole could command such motion. And yet, Sagittarius A is quiet. Some black holes blaze with energy, tearing matter apart, swallowing whole stars, and shining brighter than the galaxies that surround them. Sagittarius A is more restrained. It waits, occasionally flickering with bursts of radiation when gas falls into its grasp. But most of the time it rests in silence, a giant sleeping at the center of our home galaxy. As we linger on its size, let us consider time itself. A black hole does not simply bend space, it bends time. Near its horizon, moments stretch and slow. To a distant observer, a clock falling towards Sagittarius A would appear to tick more and more slowly, never quite reaching the boundary. To the falling object, time would feel normal, but the rest of the universe would seem to race ahead. In this way, the black hole is not only enormous in size, but in its power to reshape the flow of reality itself. Hour by hour, as we unfold the mysteries of Sagittarius A, we return to the central question: how enormous is it? Enormous in mass, enormous in influence, enormous in the way it bends both space and time. And yet, enormous is only a word. To truly sense the scale, one must imagine the galaxy itself. Billions of stars turning, drifting, held together by gravity's invisible web. At the center of it all, unseen but certain, lies Sagittarius A, the silent anchor of the Milky Way. It is vast enough to swallow millions of suns. It is wide enough to stretch across orbits of planets. It is heavy enough to command the dance of stars, and still, against the canvas of the universe, it is only one among many. Other galaxies hold even larger giants, black holes billions of times the mass of the Sun. But for us, Sagittarius A is home. It is the heart of the galaxy that carries our star, our planet, our lives. So tonight, as we begin this long journey, let the mind drift to that hidden place at the center of all things. A place of stillness, of unimaginable weight. A black hole, quiet yet enormous, binding the Milky Way together in the vast night of space. This is Sagittarius A*. We continue our journey, turning now to the very nature of black holes themselves. To understand Sagittarius A, we must step back and ask a simple question. What is a black hole? A black hole begins with gravity. Gravity is the most familiar force in the universe. It keeps our feet on the ground. It pulls a stone back to Earth when it is thrown into the air. It holds the moon in orbit, guiding the tides of the ocean. And it keeps planets turning around the sun year after year. Gravity grows stronger as mass increases. A small stone has little pull while the Earth has much more. The sun, with its enormous mass, commands the entire solar system. Yet even the sun is not strong enough to bind light itself. If a photon of light leaves the sun's surface, it escapes into the universe. A black hole, however, is something different. It is an object so dense, with gravity so intense, that not even light can escape. The boundary of a black hole is called the event horizon. It is the point of no return. If something crosses this boundary, it cannot escape, no matter how fast it moves. Imagine a waterfall where the water flows calmly until it reaches the edge. Once the water goes over, there is no turning back. The event horizon is that edge for space itself. To understand how such a boundary forms, let us imagine compressing matter. If we took the Earth and squeezed it smaller and smaller, its gravity would grow stronger. If Earth were compressed into the size of a marble, it would become a black hole. Its mass would remain the same, but packed into such a tiny space, its gravity would allow nothing to escape. The Sun, if compressed, would form a black hole just 3 kilometers across. And Sagittarius A. To create that black hole, 4 million suns have been compressed into a single region, only 12 million kilometers wide. A staggering weight, packed into a dark sphere, creating gravity so powerful that space folds around it. This leads to another idea: escape velocity. Every object has a speed you must reach to escape its pull. On Earth, the escape velocity is about 11 kilometers per second. That is why rockets must reach such speed to break free into space. The sun's escape velocity is much higher, over 600 kilometers per second. But for a black hole, the escape velocity is greater than the speed of light. Nothing moves faster than light, and so nothing can escape. This is the reason the black hole is black, for even light is trapped. And yet, though they are invisible, black holes reveal themselves in subtle ways. Their gravity shapes the orbits of stars and gas around them. Their presence can be felt in the bending of light, in the motion of nearby objects, in the flares of energy when matter falls across the event horizon. Sagittarius A is quiet compared to some, but still we see the signs. A silent gravity, pulling at the very heart of the galaxy. Let us pause to imagine standing near the event horizon. From far away, the black hole is dark, yet surrounded by glowing gas and dust. The stars orbiting nearby would blur into arcs of light, their paths curved by gravity's hand. Closer still, time itself begins to stretch. A clock on your wrist would appear to tick more slowly to someone watching from far away. If you tried to shine a light outward, it would curve and bend, struggling to escape the grip of the black hole. And then there is spaghettification, a word both playful and haunting. If you fell feet first toward Sagittarius A, gravity at your feet would be stronger than at your head. The difference would stretch you thinner and thinner, like a strand of spaghetti, until your atoms themselves were torn apart. This is not a fate we encounter in daily life, but near a black hole, the laws of physics themselves press into extremes. Still, it is important to remember that Sagittarius A is far away. From our safe place here on Earth, it is only a mystery to ponder, not a danger to fear. Its enormity is a lesson, a reminder of how strange and varied the universe can be. Black holes are not monsters. They are natural outcomes of gravity, the inevitable result of matter collapsing under its own weight. They are born from stars that have reached the end of their lives, and in the case of Sagittarius A*, from countless stars and gas clouds gathered together over billions of years. They are not alive and they do not hunt. They simply exist, quietly shaping the galaxies around them. So when we speak of Sagittarius A, we are speaking of something both terrifying and serene. A hole in the fabric of space, yes, but also a stable anchor, a quiet presence at the center of the Milky Way. Its nature is simple. It is gravity distilled to its purest form, and gravity is everywhere. It holds us to Earth. It holds the Earth to the Sun. It holds the Sun to the galaxy. And at the center, binding the galaxy itself, Sagittarius A* waits. Enormous in size, enormous in power, and yet silent, invisible, hidden in the darkness of space. As we reflect on this, consider how vast the difference is between our daily lives and the life of a galaxy. We measure our days in hours, our journeys in kilometers. But the black hole measures its influence in light years, in millions of stars, in billions of years. Its enormity is not only in size, but in scale, far beyond the reach of human experience. Still, we can imagine. And in imagination, we can approach understanding. We can picture the event horizon, the stars whirling around it, the weight of millions of suns crushed into darkness. We can imagine how small Earth is in comparison, and how immense the galaxy is beyond. We can think of gravity, pulling, shaping, guiding, from the fall of a leaf to the orbit of a star. This is the nature of Sagittarius A. It is a black hole, a place where space itself folds inward, a place where time slows, a place where mass becomes infinite density. And above all, it is enormous. We will continue this journey, unfolding more of its mystery, comparing it to other giants in the universe, and placing it within the endless story of the cosmos. But for now, remember this. At the center of our galaxy lies a presence that is both quiet and vast, an anchor that holds the Milky Way together. This is Sagittarius A, the enormous heart of our home in the stars. We continue our long exploration of Sagittarius A, turning now to the question, how do we know it is there? Black holes, by their very nature, are invisible. They emit no light, no radiation that escapes, no signal we can detect directly. They are dark, silent, hidden. And yet we have discovered Sagittarius A, measured its mass, and even glimpsed its outline. How was this possible? The answer begins with stars. In the late 20th century, astronomers began to look closely at the center of the Milky Way. Clouds of dust blocked ordinary light, but by using infrared and radio telescopes, scientists could peer through the haze. What they saw was astonishing. Stars near the galactic center were moving with incredible speed, whipping around an unseen point. One star in particular, known as S2, became a key to the mystery. It completes a full orbit around the center in just 16 years. That may sound like a long time, but consider the scale. Our own sun takes more than 200 million years to circle the galaxy. For S2 to race around the galactic center in a mere 16 years, something massive must be pulling it inward. By tracking S2's orbit, astronomers could apply the same laws of gravity that keep planets circling the sun. The result was clear. At the center of that orbit was an object 4 million times the mass of the sun. But no star could hold that weight. No cluster of stars, no gas cloud, nothing visible. The only explanation was a supermassive black hole, Sagittarius A*. Other stars confirmed the story. Dozens of them moved in graceful ellipses, some rushing to speeds of thousands of kilometers per second. Their orbits all pointed to the same invisible anchor. The evidence was overwhelming. And so, the center of the Milky Way was revealed not by what could be seen, but by what could not. It was revealed by gravity itself, the silent pull shaping the paths of stars. But astronomers did not stop there. They built vast arrays of radio telescopes, linking them across the world into one giant eye. This project, called the Event Horizon Telescope, used a technique known as interferometry. By combining signals from many dishes scattered across the globe, scientists created a virtual telescope the size of Earth itself. In 2019, this array revealed the first image of a black hole, the glowing ring of Messier 87*, in a distant galaxy. And in 2022, the same project turned its gaze on Sagittarius A. Through the dust, through the distance, through the immense challenge of imaging something that changes from moment to moment, the image emerged. What we saw was a faint, glowing halo of light surrounding a dark circle. That circle was the shadow of Sagittarius A, cast by its event horizon against the glowing gas swirling around it. For the first time in human history, we could see the outline of the enormous object that lies at the heart of our galaxy. It was not sharp like a photograph. It was blurred, shimmering, alive with motion. But it was real. It was the long-sought proof that our calculations, our measurements, our theories had been correct all along. The shadow was there just as Einstein's equations had predicted. And yet beyond the science there is something profound in this image. For centuries, black holes were only an idea born from mathematics. For decades, Sagittarius A was only a hidden influence, an unseen mass tugging at stars. And now we had seen its outline, captured its shadow, and turned the unimaginable into something visible. Consider what it means to measure such a thing. The galaxy is vast beyond measure. The black hole is tiny by galactic standards, smaller than the orbit of Mercury, and yet it lies 26,000 light-years away. To detect it required instruments stretched across continents, working in perfect unison. It required patience, precision, and the collaboration of scientists around the globe, and all of it to glimpse a silent shadow at the heart of our galaxy. This is how we know Sagittarius A, not through direct sight but through evidence. Through stars circling an invisible center, through light bent and delayed by gravity, through the faint glow of gas swirling before its fall into darkness, through the shadow captured by an Earth-sized eye turned toward the core of the Milky Way. Sagittarius A is enormous in mass, enormous in influence, and enormous in the challenge it posed to human understanding. And yet we rose to that challenge. We measured it, we imaged it, and we now carry its shadow in our collective memory. This is how we know the black hole is there. This is how we measure the invisible. This is how we reached across the galaxy with nothing but light and patience to discover the enormity of Sagittarius A*. We turn now to a question of comparison. Sagittarius A is massive, enormous beyond our imagination. But in the universe of black holes, it is not the largest. To truly understand its scale, we must place it beside others of its kind. At the heart of a galaxy known as Messier 87 lies another black hole. When astronomers unveiled the first image of a black hole in 2019, it was this one, M87*. Unlike Sagittarius A*, which holds the mass of 4 million suns, M87 is a colossus. It is 6.5 billion solar masses. That is more than 1,000 times greater than the mass of Sagittarius A. Try to imagine that difference. If Sagittarius A were the size of an orange, then M87 would be a sphere the size of a large house. Both are black holes, both are born of gravity and collapse, both bend spacetime itself, but the scale between them is staggering. And yet, despite its enormous size, M87 lies far away, about 55 million light-years from Earth. By contrast, Sagittarius A is right in our cosmic neighborhood, only 26,000 light-years distant. This is why we can study our own black hole in such detail. It may be smaller than M87*, but its nearness makes it an open window into the nature of supermassive black holes. Consider their event horizons. Sagittarius A*'s event horizon is about 25 million kilometers across, large enough to enclose the orbit of Mercury. M87*'s event horizon, however, would swallow the entire solar system with room to spare. If placed where our Sun is now, its darkness would extend beyond the orbit of Pluto. This difference reveals something profound about galaxies. Not all black holes are the same size. Some galaxies host black holes of millions of solar masses, others billions. The connection between a galaxy and its central black hole is deep, though still mysterious. A small black hole can shape a galaxy of hundreds of billions of stars. A larger one can drive enormous jets of energy, extending far beyond the galaxy's edge. Sagittarius A is relatively quiet. It feeds slowly, nibbling at gas and dust that drift too close. In radio waves and X-rays, we see faint flickers of activity, brief flares of energy. But compared to other active black holes, ours is gentle, calm, subdued. M87*, on the other hand, blazes with activity. It launches a jet of material thousands of light-years long, a beam of energy so powerful that it can be seen from across the universe. Both black holes remind us that gravity shapes more than just orbits. It shapes galaxies, it drives cosmic evolution, it regulates the birth of stars. These central objects, hidden and silent, are engines of change on galactic scales. Let us compare further. If a human were to stand near the event horizon of Sagittarius, for the moment, the impossibility of survival, time itself would slow compared to someone far away. A few minutes near the black hole might be years in the wider galaxy. The same would be true at M87*, but the effect would be stretched to even more extreme scales. Near these giants, time itself bends. This raises a humbling thought. In the cosmos, scale is everything. Our minds struggle to hold the difference between millions and billions, between orbits measured in years and in hundreds of millions of years. And yet, these are the scales that define our galaxy and others. Sagittarius A is enormous, but it is not unique. It sits within a family of black holes that range from modest supermassive giants to true titans like M87*. Together, they remind us that nature builds across a vast spectrum, from the smallest atom to the largest galactic structures. For us, Sagittarius A is special because it is ours. It anchors our galaxy. It shapes the stars near the center. It is the object we can study most closely, the one we can measure with precision. But in the cosmic sea, it is one among many. Picture it this way. If you were to scatter marbles across a floor, each marble representing a galaxy, then at the heart of nearly every marble there would be a tiny weight, a black hole, invisible yet heavy, anchoring it. Sagittarius A is the weight in our marble. M87 is the weight in another, larger marble. And across the floor of the universe, billions more weights hold billions of galaxies in balance. This perspective is vast. And yet, by comparing Sagittarius A with its larger cousins, we begin to see not just its size, but its role. It is not the largest black hole in the universe. It may not even be extraordinary by cosmic standards, but it is ours. And by knowing it, we begin to know the pattern of black holes everywhere. So how enormous is Sagittarius A? It is large enough to bind the heart of the Milky Way, small enough to be outshone by others, near enough to be our closest laboratory, and distant enough to remind us of our fragile place in the galaxy. Its enormity is not only in numbers, not only in kilometers or solar masses, but in meaning. It is enormous because it opens our eyes to the scale of the cosmos itself. At the very center of our galaxy lies Sagittarius A*, a supermassive black hole so powerful that it bends both light and time around its invisible form. To understand what happens in its presence, we must approach the edge of the event horizon, the invisible boundary beyond which return is impossible. The event horizon is not a surface made of matter. It is not a shell, nor a wall you could touch. Instead, It is a boundary woven into the very geometry of spacetime. Think of the cosmos as a great flowing river, carrying everything along with it. The event horizon is like the edge of a waterfall. From a distance, you can float safely, held in the current, and perhaps paddle back to calmer waters. But if you drift too close, if you cross that invisible line, the river becomes unstoppable, and every possible path forward carries you deeper toward the abyss. Near Sagittarius A, this horizon spans about 12 million kilometers across. To imagine its scale, consider our own Earth, barely 12,000 kilometers wide. The horizon of Sagittarius A dwarfs our entire planet 1,000 times over. Yet compared to the vastness of the Milky Way, it is but a pinprick, a shadowed heart hidden among billions of stars. The first strange effect awaiting us here is time dilation, predicted by Einstein's general theory of relativity. Time does not pass at the same rate everywhere. Near massive objects, gravity stretches and slows the passage of time. If you hovered in a ship just above the horizon of Sagittarius A, your own clock would tick normally. You would feel no change in your heartbeat, no delay in your speech, no hesitation in your thoughts. Yet to a distant observer watching from a safe distance in space, your clock would seem to slow. Every second you lived would appear longer, stretched out into eternity. From their perspective, as you drift closer and closer to the horizon, your motion would slow until you seemed frozen in place, trapped forever at the edge. To you, however, nothing unusual would happen until the very moment you crossed over. This dual reality is one of the most puzzling and beautiful truths of black hole physics. The same event is seen in two utterly different ways. The outside world sees you linger forever at the brink, fading, dimming, slowing, as if time itself has stopped. Yet from your own point of view, time continues without pause, carrying you smoothly across the threshold and inward to a realm no signal can escape. Beyond time dilation lies another consequence: spaghettification. Gravity does not act equally on every part of an object. It pulls more strongly on the side closer to the source. For a person falling feet first towards Sagittarius A, the pull on the legs is stronger than the pull on the head. The body stretches, elongates, thins. You become a thread, drawn out into extraordinary length. This is not a poetic exaggeration. It is a physical effect of tidal gravity. Yet, paradoxically, Sagittarius A is so massive that the tidal forces at its horizon are surprisingly gentle. For a smaller black hole, perhaps the mass of a star, spaghettification begins long before reaching the horizon. But with Sagittarius A, you could cross the event horizon without immediately sensing the strain. The stretching would grow only deeper inside, where the singularity draws you with irresistible force. The very atoms of your body would be pulled apart, molecules unraveling, matter disassembled into pure energy and curvature of spacetime. Here, another astonishing truth emerges. Outside the horizon, we live in a universe where space is something we move through, and time is something that moves us forward. But inside the horizon, those roles begin to change. Falling inward is no longer an option. It becomes a requirement, as compulsory as tomorrow arriving after today. Inside, the direction toward the singularity becomes as unavoidable as the flow of time itself. You cannot resist it. You cannot pause. Every step forward in your personal timeline is also a step deeper into the black hole's core. Imagine this carefully. Outside the black hole, you are free to walk north, south, east, or west. But time only allows one direction, forward. Inside the horizon, forward in time and inward toward the singularity are the same. All paths lead inward. There is no standing still, no circling back, no alternative route. To exist inside is to be carried toward the center, with no more freedom than we have to stop tomorrow from coming. This is why the event horizon is a boundary not only of space, but of knowledge. It is the point where our familiar understanding of reality loses its footing. We can describe the equations. We can predict how matter behaves. But the lived experience of passing through is sealed away, hidden forever from the outside universe. No message can escape to tell the tale. Even light itself cannot resist. Light, which normally races through the universe at the ultimate speed limit, finds its path bent, looped, and finally swallowed. As light struggles near the horizon, its waves stretch longer and longer, fading from visible to infrared, from infrared to radio, until they vanish into silence. To an outside eye, the last signals from an object crossing the horizon arrive slower, dimmer, weaker, until they fade altogether. What remains is the black hole's shadow, the dark imprint left on the glowing matter behind it. Astronomers, using vast arrays of telescopes across Earth, have captured this shadow. They have not seen the black hole itself, for it cannot be seen, but they have imaged the absence it creates. The silhouette carved into spacetime. That shadow is not a surface. It is not a material thing. It is the outline of distorted light, the lingering proof of the event horizon's invisible edge. To linger at this boundary in thought is to enter a paradox. From far away, you are frozen, timeless, never quite vanishing. Up close, you are free-flowing, carried without pause into the unknown. Space becomes time, time becomes space, and our deepest intuitions collapse into mystery. Imagine now that you are there, floating above Sagittarius A. The stars around you shimmer and twist, their light bent into arcs and rings by gravity. Some stars multiply, appearing in strange duplicates as their light takes multiple paths around the hole to reach your eyes. Others vanish behind the curve of spacetime. The galaxy itself becomes a distorted painting, smeared across the sky. And there at the center is the dark circle, a void not of emptiness but of inevitability. As you drift closer, the halo of light thickens. The stars blur into streaks, circling endlessly around the shadow. Your heartbeat still feels steady. Your thoughts still move at their ordinary pace. Yet far away, any observer would see you as slow as a whisper, your moments stretched across centuries. The two perspectives will never agree, never reconcile, because the physics of a black hole allows both to be true at once. This is what makes Sagittarius A so much more than enormous in size or mass. It is enormous in its influence on reality itself. It reshapes time, it reshapes matter, it reshapes the very idea of cause and effect. To contemplate it is to stretch our own minds, to admit that the universe holds places where intuition no longer guides us, and where reality itself bends into forms that border on the incomprehensible. Here, on the threshold of Sagittarius A, we find the ultimate test of our understanding, the place where space, time, matter, and energy all dissolve into something beyond our current grasp. It is not only a black hole, it is the boundary of what can be known. Around Sagittarius A lies one of the most dramatic features in all of astrophysics, the accretion disk. Unlike the invisible event horizon, the accretion disk is made of ordinary matter, gas, dust, and stellar debris, but gathered into extraordinary shapes and motions. It is here that the presence of the black hole becomes visible, not through the hole itself, but through the way it sculpts and ignites the matter around it. An accretion disk forms when material falls toward the black hole but cannot plunge straight in. Instead, like water circling a drain, the matter spirals, flattened into a thin, spinning structure. In this disk, particles collide and rub against one another, and friction generates heat. But the heat here is beyond anything we can imagine on Earth. Temperatures soar into the millions of degrees. At such temperatures, atoms are stripped apart into plasma, glowing with powerful radiation. To the human eye, this would appear not as gentle light, but as blinding brilliance, X-rays and gamma rays far more energetic than anything visible. Around Sagittarius A, the disk does not always shine so fiercely, because the black hole is not constantly feeding. Sometimes, it rests in relative quiet, only flaring when a star or gas cloud wanders too close. Yet when it does awaken, the accretion disk becomes one of the brightest objects in the galaxy's heart, outshining entire clusters of stars. The spiraling motion of the disk is not just beautiful, it is violent. The inner regions orbit at nearly the speed of light. Imagine a planet like Earth circling the Sun once per year. In the innermost regions of an accretion disk, matter circles Sagittarius A in mere minutes. The forces are so intense that the very shape of space bends under the rotation. From these inner regions, another phenomenon arises: relativistic jets. These are vast streams of charged particles, launched not into the black hole but outward, shooting across the galaxy at near-light speeds. The precise mechanism behind jets remains one of astrophysics' most profound mysteries. We believe that the black hole's immense magnetic fields twist and funnel the plasma, accelerating it along the poles of rotation. The result is a pair of cosmic lighthouses, beaming matter and energy thousands of light-years into space. For Sagittarius A, these jets are not always active. They flare occasionally, revealing that the black hole has tasted new matter. Astronomers have found evidence that, millions of years ago, our black hole may have launched much larger jets, shaping the very structure of the Milky Way. Today, we can still see echoes of that past in gigantic gamma-ray bubbles extending far above and below the galactic plane, remnants of ancient outbursts. This means that Sagittarius A is not just a silent observer. It is an architect, influencing the galaxy that surrounds it. Its gravity binds the orbits of stars near the center. Its past activity may have regulated the flow of gas, shaping how new stars were born or prevented from forming. It is both destroyer and creator, a force that consumes matter in one breath and seeds new structures in another. When we look at the Milky Way, stretching as a band of light across our sky, every star in that river belongs to a galaxy organized by the pull of Sagittarius A. Without it, the motions of stars near the center would be chaotic. With it, the heart of the galaxy remains bound, its stars weaving graceful orbits around an unseen center. Consider the stars closest to Sagittarius A. They whirl around the black hole at breathtaking speeds, completing orbits in just a few years. Astronomers have tracked these stars for decades, watching them dance around an empty space. Their paths reveal the black hole's presence, for nothing else could provide such gravitational pull. These stellar orbits were among the first direct pieces of evidence proving Sagittarius A exists. They show us that something weighing millions of suns lurks in a region no larger than our solar system. Now imagine the scales involved. A star like our Sun would take hundreds of millions of years to orbit the galaxy once. Yet stars near Sagittarius A complete their circuits in mere decades. Their movements are like clock hands racing around an invisible dial. And all of this is controlled by a single point of gravity, the black hole at the center. The accretion disk, the jets, and the stars around it are reminders that Sagittarius A is not isolated. It is connected to the galaxy in every way. Its appetite, its bursts of activity, and its immense pull shape the history of the Milky Way itself. If you could drift above the galactic plane and look down upon the Milky Way, you would see its spiral arms stretched across 100,000 light-years, a glowing pinwheel of stars. At the very hub of that pinwheel, buried in dust and hidden from ordinary sight, lies Sagittarius A. It is small compared to the galaxy's vastness, but it anchors the entire structure. The galaxy revolves around this center, held together by the unseen weight of its supermassive heart. To think of Sagittarius A in this way is to recognize its dual nature. It is both a destroyer of matter and a guardian of order. It is a silent eater of stars and a conductor of galactic harmony. The black hole does not simply exist at the center, it defines what the center is. Without it, the Milky Way would not be the galaxy we know. In contemplating the accretion disk, the jets, and the galactic influence of Sagittarius A, we are reminded that black holes are not just isolated voids. They are engines of cosmic evolution. They are the power sources that regulate galaxies, ignite quasars, and sculpt the universe on scales that dwarf our imagination. And at the heart of our own galaxy, Sagittarius A plays this role quietly, invisibly, but with immense significance. To fall into its presence is to witness the transformation of matter into light, of gas into energy, of gravity into motion. It is to see how destruction and creation intertwine, how the darkest of objects can illuminate the skies, and how the invisible can shape the visible in ways more profound than any star could manage alone. At the heart of Sagittarius A, deeper than the glowing accretion disk, deeper than the event horizon, lies the singularity. This is the innermost mystery, the place where gravity becomes infinite, and where our understanding of physics reaches its limits. To approach the singularity in thought is to step beyond the edge of what we know. It is not a place in the ordinary sense, for space itself has collapsed. It is not a moment in time, for time itself has broken. The singularity is the point where all the mass of the black hole, millions of suns worth, is compressed into something smaller than a grain of sand, smaller than an atom, perhaps even smaller than a point with no size at all. General relativity. Einstein's great theory of gravity predicts this collapse with relentless certainty. In its equations, matter falling into a black hole is squeezed tighter and tighter, the density rising without end. At the singularity, the mathematics produce infinities, values that no longer make sense. It is as if the language of physics falls silent, unable to describe what truly lies there. This silence is not a failure of curiosity, but a clue. It tells us that relativity alone cannot explain the singularity. To go further, we need a deeper theory, one that unites gravity with quantum mechanics, the physics of the very small. But such a theory, often called quantum gravity, does not yet exist in complete form. The singularity, then, is not only a mystery of nature, but a challenge to science itself. There are many ideas. Some suggest that the singularity is not a point, but a region where spacetime itself becomes quantized, broken into indivisible units smaller than anything we can imagine. Others propose that what we call a singularity may conceal new dimensions of reality, hidden folds of the universe that open only under such extreme conditions. There are even theories that black holes might act as bridges, connecting our universe to others, though such speculations remain far beyond proof. What we do know is that the singularity is hidden forever from outside view. The event horizon seals it away, locking its secrets behind a veil no light can cross. No matter, no signal, no information can escape to tell us what the singularity is truly like. We infer its presence only from the way the black hole influences the world around it, from the orbits of stars, from the glow of the accretion disk, from the shadows captured by telescopes. The singularity itself remains an eternal enigma, yet even without seeing it, we can sense its power. Everything that crosses the horizon is destined for it. Space itself curves inward, time itself points toward it, and all possible paths end at the same destination. It is not only the center of the black hole, but the inevitable future of everything drawn inside. To imagine standing near it, if such words even make sense, is to imagine a place where the familiar scaffolding of reality collapses. Distances lose meaning because there is no space left to measure. Durations lose meaning because time itself has ceased to flow in any recognizable way. Our concepts of before and after, here and there, dissolve. The singularity is not merely a location. It is the breakdown of the very fabric of the cosmos. And yet, hidden in this breakdown may be the seeds of new understanding. Some physicists believe that studying black holes will reveal the long-sought union of relativity and quantum theory. The singularity might be the key to unlocking how the universe began, for the conditions near it echo the conditions of the Big Bang: infinite density, infinite energy, a birth from what seems like nothing. To understand Sagittarius A at its core may be to understand the origin of everything. It is humbling to realize that within our own galaxy, only 26,000 light-years away, lies such a puzzle. We orbit our sun, we look at our night sky, and at the center of that sky rests a silent object that challenges the boundaries of human thought. We cannot see it, we cannot touch it, but its existence forces us to confront the limits of knowledge and to admit that reality may be far stranger than our equations suggest. The singularity of Sagittarius A is not simply a dot of infinite density. It is a mirror held up to our understanding, reflecting both the power of what we know and the vastness of what we do not. To contemplate it is to stand at the edge of mystery, gazing into a depth where language falters but wonder endures. In the heart of every great galaxy, there seems to lie a mystery, and in most cases, that mystery takes the form of a supermassive black hole. Sagittarius A, at the core of our Milky Way, is not unique in this regard. Rather, It is part of a vast cosmic pattern, one that links the growth of galaxies to the gravity wells at their centers. What we see in Sagittarius A is a quieter echo of a drama that has played out across the universe for billions of years. When astronomers first discovered quasars in the 1960s, they were astonished by their brilliance. Here were objects so bright they could outshine entire galaxies, visible across billions of light years. At first, no one could imagine what might produce such energy. Yet the answer turned out to be black holes, not ordinary ones, but giants millions or even billions of times the mass of the Sun, consuming matter at furious rates. The disks of gas spiraling into them released energy not in modest bursts, but in torrents, making quasars some of the brightest beacons in the universe. In these cosmic furnaces, the story of galaxy formation is written. For as much as quasars shine, they also shape. The energy released near the black hole pushes outward, creating powerful winds and jets that race across interstellar space. These outflows sweep through galaxies, stirring gas, compressing it in some places while blowing it away in others. In doing so, the black hole both nurtures and suppresses the birth of stars. It acts as a regulator, a cosmic thermostat, preventing galaxies from becoming too bloated with star formation while ensuring they never go entirely cold. Our Milky Way is a calmer environment now. Sagittarius A rests in a state of relative silence, feeding only on sparse trickles of gas and the occasional star that wanders too close. Yet the evidence suggests it has not always been so. There are faint echoes in the sky, vast bubbles of high-energy radiation stretching tens of thousands of light-years above and below the galactic plane. These Fermi bubbles, discovered by space telescopes, may be the fossil record of an earlier outburst, when Sagittarius A flared with much greater power. If true, it means our black hole once roared like a quasar, altering the Milky Way itself. The connection between black holes and galaxies grows even deeper when we study their masses. Time and again, astronomers have found a surprising correlation. The larger the central bulge of stars in a galaxy, the larger its central black hole. This is not a trivial coincidence, for it implies a shared evolution. Galaxies and their black holes grow together, feeding from the same reservoirs of gas, influencing one another across eons. The black hole anchors the galaxy, not merely through gravity, but through its role in shaping how the galaxy matures. Consider the universe in its earliest epochs. Just a few 100 million years after the Big Bang, quasars already blazed, their supermassive black holes improbably massive for such a young cosmos. How did they grow so fast? This remains one of the great mysteries of cosmology. Perhaps they were born from the collapse of enormous clouds of primordial gas, bypassing the slower path of star formation. Or perhaps smaller black holes merged repeatedly, creating titans in the dark. Whatever their origin, their influence was profound. They flooded the young universe with light and energy, helping to reionize the fog of hydrogen that once filled all of space, making the universe transparent to starlight. In this way, black holes were not merely passengers in the story of cosmic evolution. They were actors, essential to the unfolding of the universe's grand design. Without them, galaxies might never have taken their familiar shapes. Star formation might have run unchecked, leaving galaxies unstable and chaotic. Instead, the balance enforced by black holes allowed for the steady creation of long-lived systems, within which stars could cluster, planets could form, and eventually life could emerge to contemplate it all. To walk beneath the stars and gaze toward the Milky Way's center is to feel this connection. Somewhere in that dense, glowing band of light, Sagittarius A lies hidden, invisible yet sovereign, holding the galaxy together while whispering of ancient fires long extinguished. Its silence today is not the silence of irrelevance, but of patience, the patience of an engine that has already sculpted much of what we see around us. As we look outward, across billions of light years, we see this pattern repeating endlessly. Every galaxy with a bulge, every quasar with its blinding light, every jet carving through intergalactic space, all of them point back to the same truth. black holes are more than the end of matter. They are part of the beginning of structure. They are not simply destroyers, but creators in disguise, shaping the cosmos in ways we are only beginning to understand. In the end, Sagittarius A is a reminder that the universe is not built only by the visible, but by the invisible, by the quiet gravity of things unseen, by forces that do their work in silence, over spans of time longer than any civilization, longer than any species, longer even than the lifetimes of stars. To grasp the role of Sagittarius A in the story of galaxies is to grasp the profound interdependence of all things, the stars, the planets, the light, the dark, and the deep engines that bind them together. When we look at Sagittarius A, quiet yet immense at the core of our galaxy, we cannot help but wonder about the larger story it participates in. If black holes endure beyond the lifetime of stars, beyond the cycles of galaxies, then perhaps they hold clues not only to the past of the universe, but also to its farthest future. The universe began in fire, an expansion from a dense, hot origin we call the Big Bang. But how will it end? Here, cosmology offers several possibilities, each shaped by the forces that govern space and time. And in each scenario, black holes play a starring role. One vision is the Big Freeze. In this model, the expansion of the universe continues forever, powered by dark energy. Galaxies drift farther and farther apart, their stars burning through their fuel until nothing remains but cold embers. In this future, black holes like Sagittarius A become the last great structures, quietly holding what mass is left. For trillions upon trillions of years, they will outlast stars and nebulae, silent titans in an increasingly empty universe. Only after an unfathomable stretch of time will they begin to evaporate through Hawking radiation, releasing their mass as faint streams of particles. The end is not violent, but a long fading, a cosmos dying in silence and cold. Another possibility is the Big Rip. If dark energy grows stronger with time, the expansion of the universe will not simply continue, it will accelerate without limit. Galaxies will be torn apart. Stars will be ripped from their orbits. Even planets and atoms may eventually be stretched into nothingness. In such a scenario, not even Sagittarius A could endure. The very fabric of space would unmake itself, and black holes would be destroyed not by evaporation, but by the relentless tearing of the cosmos. The universe would not fade slowly, but come undone in a final, catastrophic dissolution. A third possibility is the Big Crunch. Here, the story reverses. If gravity one day overpowers expansion, the universe might stop stretching and begin contracting. Galaxies would fall toward one another, stars would collapse together, and eventually all matter might converge into an ultimate singularity, a mirror of the Big Bang, but in reverse. In such a fate, black holes like Sagittarius A could merge with others, growing larger and larger until everything is drawn inward. The end would be an ocean of collapsing horizons, merging into a final, universe-sized black hole. And then there is the cyclic universe, the idea that the cosmos may not have only one beginning and one end, but many. In this model, the Big Crunch may trigger a new Big Bang, an endless series of expansions and contractions, births and deaths. If this is true, then Sagittarius A and black holes like it are not only participants in one story, but recurring players in an eternal cycle, written across the ages of time. In each of these visions, black holes stand at the threshold between what we know and what lies beyond. They are the final keepers of matter, the last to fade in a frozen universe, the first to dominate in a collapsing one, or the silent companions of endless cycles. Even in speculation, they force us to widen our imagination, to think on scales far beyond human lifetimes. For the Milky Way, Sagittarius A, is enormous enough to bind a galaxy together. But in the grander picture, its enormity is also symbolic. It represents the persistence of structure against entropy, the endurance of gravity against the pull of expansion, the stubborn silence of matter against the vast emptiness of space. Whether the universe ends in freeze, rip, crunch, or rebirth, black holes are there at the center of the tale, shaping the last acts as surely as they shape the first. And so, when we ponder the enormity of Sagittarius A, we are also pondering the enormity of cosmic destiny. A black hole is more than a collapsed star. It is more than a silent anchor. It is, in some sense, a mirror in which the universe glimpses its own fate. When we reflect on Sagittarius A, it is easy to be overwhelmed by its scale, its physics, its hidden violence. But beyond the numbers and the equations, there is a deeper current flowing. The way these mysteries resonate with us, the way they invite us to contemplate not only the universe but ourselves. Human beings have always sought meaning in the skies. Long before telescopes, long before mathematics, we traced patterns in the stars, told stories about the shapes they formed, and imagined the heavens as a stage for gods and heroes. Today, our tools are sharper. We measure the faint wobbles of stars to map orbits around invisible giants. We chart the energy of quasars billions of light years away. We calculate how spacetime bends and twists around a mass so dense that even light cannot escape. Yet the impulse is the same as it was for our ancestors: to look upward, to wonder, to ask what it means. Sagittarius A becomes not only a black hole at the center of the Milky Way, but a mirror at the center of our own imagination. It forces us to confront scales of space and time that dwarf our brief lives. It reminds us that the Earth, with all its struggles and triumphs, circles one ordinary star in a galaxy of hundreds of billions, and that galaxy itself is one among countless others. To face such enormity can feel humbling, even unsettling. And yet, within that humility lies a kind of quiet strength. For what does it mean that creatures as small and fragile as we are can even ask these questions? What does it mean that atoms forged in the hearts of ancient stars have come together in such a way that they can reflect on the collapse of stars, on the birth of galaxies, on the possibility of new universes beyond the event horizon of Sagittarius A? The black hole is vast, but the mind that contemplates it is vast in its own way. Perhaps this is the greatest gift of such mysteries. They stretch us. They ask us to expand our imagination, to think in timescales of trillions of years, in distances measured not in miles but in light. They ask us to accept that we may never know the full truth, that the event horizon is not only a physical boundary, but a boundary of knowledge itself. And yet, we continue to wonder. There is philosophy in this, as much as physics. The thought that every end may also be a beginning echoes not only in cosmology, but in the rhythms of human life. Stars are born and they die, but their death gives rise to new elements, new worlds, new forms of life. Civilizations rise and fall, yet each leaves something behind that seeds the next. So too with us as individuals. We live, we change, and when our time ends, something of us remains, woven into the fabric of those who come after. The black hole, then, is not alien to us, but strangely familiar, an ultimate version of the cycles we already know. To meditate on Sagittarius A is to meditate on impermanence, on transformation, on the possibility that endings are never as final as they seem. It is to realize that destruction and creation are two faces of the same cosmic dance. It is to understand that we are small, yes, but also deeply connected to the vastness that surrounds us. And perhaps that is where meaning is found. Not in conquering the universe or fully understanding it, but in recognizing our place within it, as observers, as storytellers, as participants in its unfolding. We may never know what lies beyond the horizon of Sagittarius A, but in asking the question, we take part in the same mystery. Our curiosity becomes an act of creation, one that echoes the very processes we seek to understand. In the end, the enormity of Sagittarius A is not only physical, it is existential. It reminds us that we are part of a universe still being written, a story without a final page. And though our lives are brief, our questions stretch outward, touching the infinite, as if in wondering about the black hole, we too are reaching across horizons, into something beyond ourselves. The journey of contemplating Sagittarius A begins with a question of size. How enormous is this black hole at the heart of our galaxy? We learn the figures: 4 million times the mass of the Sun, a gravitational anchor around which the Milky Way orbits, a region so dense that space and time bend into forms almost beyond imagination. We picture stars like S2, racing in tight orbits around an invisible center, their paths proving the reality of this unseen giant. From there, the story grows. We discover that Sagittarius A is not unique, but part of a universal pattern. Every great galaxy seems to cradle a supermassive black hole at its core. These entities are not only the remnants of collapsed stars, but cosmic architects, shaping the formation of galaxies, regulating the birth of stars, and perhaps fueling quasars so brilliant that they light up the young universe. Their influence stretches from the smallest scales of atoms torn apart at the event horizon to the largest scales of cosmic evolution itself. We travel closer, imagining the strange physics at play near the horizon: time slowing, light bending, matter stretched into thin threads by gravity's grip. We reflect on the mystery of singularities, on the breakdown of our physical laws at the deepest point of collapse. Here, Sagittarius A becomes more than an object of science. It becomes a symbol of the unknown, of the boundaries of knowledge, of the places where human reason reaches its limit, and yet dares to ask, what lies beyond? We step back again to see the role of black holes in the fate of the cosmos. Whether the universe ends in silence through a big freeze, or in violence through a big rip, or in rebirth through cycles of expansion and collapse, black holes are always present. They are the last keepers of matter, the final witnesses to time. Perhaps they even hold the seeds of new universes, each singularity flowering into a new creation beyond the veil of our perception. In this speculation, black holes transform from destroyers into creators. They remind us that endings may also be beginnings, that collapse may also be transformation, that silence may also be gestation. Sagittarius A becomes not just a void, but a womb of possibility, a hidden chamber where the universe may be writing new stories even as it closes old ones. And all the while, these reflections circle back to us. We, too, are participants in this cosmos. We are made of atoms forged in ancient stars, orbiting a common center like countless others in the Milky Way. Our lives are brief compared to cosmic time, yet in that brevity we have found the capacity to wonder, to measure, to imagine. We cannot see past the event horizon, but we can dream of what it hides. We cannot stop the universe from fading, but we can give it meaning by telling its story. The enormity of Sagittarius A is not only measured in solar masses or kilometers. It is measured in its ability to draw together physics and philosophy, science and wonder, the vast and the intimate. It shows us the structure of galaxies, the fate of matter, the boundaries of time. And it shows us ourselves, small but luminous, fragile but curious, fleeting but capable of grasping the infinite with the reach of imagination. As the long meditation comes to its close, we are left not with answers but with perspective. The black hole at the center of our galaxy will endure for billions upon billions of years, silent and unseen, shaping the Milky Way long after we are gone. But here, in this moment, we have turned our thoughts toward it. We have stretched our minds across light years and epochs, into horizons and beyond them. And in doing so, we have touched a truth that matters as much to us as to the stars, that we belong to a universe vast and mysterious, a universe whose enormity humbles us, but also uplifts us, drawing us toward wonder without end. To reflect on Sagittarius A is to reflect on the heart of the cosmos itself. It is to recognize that the universe is not only out there, but within us, that the same laws shaping the stars shape our bodies, that the same mysteries pulling on galaxies pull on our thoughts, and that in contemplating the black hole, we are contemplating our place in existence. And so the story rests. Sagittarius A remains where it has always been, hidden in the center of the Milky Way, immense, patient, eternal on timescales beyond measure. We carry its image with us, not as a picture of darkness alone, but as a reminder that even in the deepest unknown, there is beauty, there is connection, and there is meaning. The enormity of Sagittarius A is the enormity of the universe itself, a silence that speaks, a mystery that inspires, a horizon that forever calls us to look beyond. Sagittarius A is not visible to the human eye, hidden behind vast clouds of interstellar dust in the direction of the constellation Sagittarius. To see it, astronomers must use radio waves, infrared light, and X-rays, which can pierce through the obscuring layers of the galactic core. These observations reveal a restless region of space, glowing faintly from matter orbiting the black hole, matter heated to extraordinary temperatures before vanishing forever across the event horizon. The black hole itself lies about 26,000 light-years away from Earth. To put this in perspective, the light that reaches our telescopes today left the center of the galaxy during humanity's earliest days, when modern humans were first spreading across the continents. Each observation is not only a look across distance, but across time. We are seeing Sagittarius A not as it is now, but as it was when our species was just beginning its long J. Sagittarius A is classified as a supermassive black hole, with a mass estimated at 4.3 million suns. Yet compared to the largest known black holes in the universe, it is modest. Some black holes at the centers of giant galaxies are thousands of times larger, reaching 10 billion solar masses or more. What makes Sagittarius A unique is its proximity. It is our nearest laboratory for studying these cosmic phenomena, the one black hole whose influence we can measure star by star. The environment around Sagittarius A is a turbulent sea of radiation, gas clouds, and fast-moving stars. Some of these stars orbit astonishingly close. One of the most famous is S2, which completes an orbit in just 16 years, whipping around the black hole at speeds over 7,600 kilometers per second. Watching S2's path has given astronomers direct proof of general relativity in action, as its orbit shifts slightly due to the warping of spacetime itself. Although Sagittarius A is massive, it is surprisingly faint. Astronomers sometimes call it a starved black hole. Unlike quasars, which shine across the cosmos by devouring immense amounts of matter, Sagittarius A consumes only small scraps, the occasional star, cloud, or fragment of gas. In fact, if you stood near the galactic center, protected somehow from the radiation, the black hole would not appear blinding. Its faintness makes it all the more mysterious. A giant that whispers rather than roars. Scientists also suspect that Sagittarius A was more active in the past. Evidence of ancient outbursts remains imprinted on the Milky Way itself. Vast bubbles of gamma rays, called the Fermi bubbles, extend tens of thousands of light-years above and below the galactic plane. These glowing lobes may be remnants of a time when Sagittarius A fed more aggressively, blasting energy outward in a colossal display. Today, we live in the quiet afterglow of that ancient fire. To think of Sagittarius A is to think of balance, an object so dense that nothing escapes, yet so subtle in its influence that its presence is known only through the dance of stars and the faint flicker of radiation. It is immense in mass, but quiet in demeanor. It anchors the galaxy, but reveals itself only reluctantly, as though reminding us that not all power is loud, and not all enormity is easily seen. When a star drifts too close to Sagittarius A, it enters a realm where gravity's pull is relentless and unforgiving. At first, the star may seem unharmed, circling as though caught in a dance. But as it edges closer, tidal forces begin to stretch it. Gravity pulls more strongly on the side near the black hole than on the far side, and this difference tears the star apart in a process astronomers call a tidal disruption event. The star unravels into a stream of gas, stretched thin and elongated like a ribbon of light. Part of this stellar material falls inward, spiraling toward the black hole, heating to millions of degrees as it rubs against itself and forming a temporary accretion disk. The gas glows with X-rays, sometimes outshining the rest of the galaxy for weeks or months. The other part of the star is flung outward into space, scattered across the galaxy like ashes from a cosmic fire. Though Sagittarius A is quiet now, it has witnessed such feasts in the past. Astronomers have observed echoes of these events in bursts of energy and flares of radiation coming from the galactic center. Each tidal disruption reminds us that the black hole is not merely a passive anchor but a predator lying in wait. It does not chase its prey. It simply waits for the cosmos to deliver it. For the star, the encounter is the end. But for the galaxy, it is part of the cycle of transformation. The matter that falls in is lost to us forever, hidden beyond the horizon. The matter that escapes enriches the galactic environment, seeding new clouds, new stars, perhaps even new planets. Out of destruction comes renewal, and Sagittarius A becomes both devourer and giver, a paradox at the heart of the Milky Way. Looking forward, Sagittarius A will continue to play its silent role as the anchor of the Milky Way. Stars will keep circling it in their orbits, some closer, some farther, each one moving to the rhythm of its gravity. Occasionally, another star or gas cloud will wander too near, sparking a flare of activity. But in general, it will remain quiet, patient, enduring. Yet even in its silence, it holds the galaxy together. Without Sagittarius A, the stars of the Milky Way would not have the same stable center of gravity to orbit. The spiral arms that give our galaxy its graceful shape depend on the black hole's presence. It is not merely a feature of the galaxy, it is its foundation. Billions of years from now, Sagittarius A will still be here. The sun will have burned out, Earth will have long ceased to exist, but Sagittarius A will endure, a shadowy constant at the center of a galaxy transformed. As time stretches further, galaxies will collide and merge. In fact, astronomers know that in about 4 billion years, the Milky Way will merge with its nearest neighbor, the Andromeda Galaxy. When that happens, Sagittarius A will encounter Andromeda's central black hole. The two giants will spiral toward one another, merging into an even larger black hole, perhaps tens of millions of solar masses in size. This merger will reshape the galaxies, scattering stars into new patterns, lighting up the night skies of distant civilizations, if any remain to see it. Out of two galaxies, one will emerge, bound by a new black hole, even more enormous than Sagittarius A alone. And beyond that, in the far future, long after galaxies have merged and stars have burned out, Sagittarius A will remain among the last actors on the cosmic stage. Black holes are survivors. They outlast the stars, the galaxies, and perhaps the universe itself. Whether the cosmos ends in endless expansion, in collapse, or in transformation into something new, Sagittarius A will be there, silent and immense, carrying its secrets across eternity. The great encounter between the Milky Way and the Andromeda Galaxy is one of the most spectacular events written into our cosmic future. Though the galaxies are rushing toward each other at nearly 110 kilometers per second, the vast distances between stars mean that direct collisions of suns will be rare. Instead, the two spirals will pass through one another, their shapes distorting under mutual gravity, their arms flung into tidal streams stretching across hundreds of thousands of light years. For billions of years after the first encounter, the galaxies will weave around one another in a gravitational embrace. Their stars will be hurled into new orbits, some cast into intergalactic space, others drawn toward the new galactic core. Gas clouds will crash together, sparking waves of star formation, igniting the darkness with fresh light even as older stars drift into unfamiliar skies. At the center of this dance lie two supermassive black holes, Sagittarius A and Andromeda's black hole, estimated at around 100 million solar masses, vastly larger than our own. As the galaxies merge, the two black holes will slowly spiral inward, pulled together by their combined gravity and by the drag of surrounding stars and gas. For a long time, they will circle each other, a binary pair radiating invisible waves of gravitational energy into space. Eventually, the orbit will decay, and the black holes will collide. The merger will release more energy in gravitational waves than all the stars of the new galaxy emit in light. Yet from afar, it will pass silently, the ripples spreading through spacetime itself. The end result will be a single, even larger black hole, anchoring the core of the new galaxy, often called Milkomeda. Sagittarius A will lose its individuality, absorbed into a colossal new heart, perhaps 100 million suns in mass. This new black hole will feed on gas driven inward by the merger, igniting one of the brightest beacons in the universe. Its accretion disk will flare, outshining all the stars of the combined galaxy for a time. Jets of energy may erupt from its poles, spearing intergalactic space with streams of radiation that stretch for thousands of light years. For millions of years, Milky will shine as a quasar, visible across cosmic distances, proclaiming the violence and creativity of galactic union. In time, the storm will subside. The gas will be consumed or expelled, the jets will fade, and the stars will settle into orbits around their new merged core. Milky will become an elliptical galaxy, rounder, less structured, quieter than the spirals that gave birth to it. The central black hole, once Sagittarius A, will remain its ruler, a monarch grown vast from collision, now silent again but heavier, darker, and even more powerful. But the story does not end there. Trillions of years will pass and the stars of Milky will age and die. No new stars will be born once the gas is gone, and the galaxy will dim into a collection of stellar remnants, white dwarfs, neutron stars, and black holes. The central giant will continue to feed, swallowing unlucky stragglers, merging with smaller black holes that drift inward. With each encounter, it will grow still larger, its influence reaching farther. In the deep future, when the universe itself stretches colder and darker, when galaxies drift apart and the night sky empties, the descendant of Sagittarius A will remain. It will be one of the last structures standing, a remnant of a remnant, a monument to the creativity and destruction of the cosmos. And long after light has faded from the stars, it may slowly evaporate through Hawking radiation, releasing its mass in the faintest whispers of particles, taking untold trillions upon trillions of years to vanish. The enormity of Sagittarius A is not only in what it is today, but in what it will become, a participant in the grand cycles of galactic life, a survivor of collisions, a seed of quasars, and a relic destined to endure until the universe itself grows old. Its journey stretches far beyond hours, into epochs where time itself feels eternal. And in contemplating that future, we glimpse not just the fate of a galaxy, but the profound endurance of gravity's deepest mysteries. The story of Sagittarius A leads us from the heart of our galaxy to the edge of imagination, from the physics of mass and gravity to the quiet philosophy of existence. It begins with numbers, 4 million suns compressed into a sphere no larger than a planetary orbit, but it ends with something greater, the recognition that such enormity is not only physical but symbolic. For us, Sagittarius A is both distant and intimate. It lies 26,000 light-years away, hidden behind veils of gas and dust, invisible to our eyes. And yet its gravity shapes the Milky Way, cradles our sun in its orbit, and indirectly sustains the world on which we live. To know of it is to know that the galaxy itself is bound together by a single, unseen presence. In that sense, we are already connected to it. Every day, every orbit, every sunrise is part of its influence. But beyond its role as an anchor of stars, Sagittarius A invites us to reflect on cycles. Stars are born, they shine, and they die, sometimes giving rise to black holes. Galaxies collide, black holes merge, and new galaxies form. Even the universe itself may one day collapse or dissolve, only to give birth to something else. Sagittarius A, like all black holes, is a reminder that endings are rarely final. They are transitions, passages to something unknown, perhaps even something greater. When we contemplate this, we are really contemplating ourselves. Our lives are brief compared to cosmic scales, but in that brevity we find a mirror of the universe's rhythms. We are born, we change, we end, yet what we leave behind continues. Atoms forged in stars long ago now compose our bodies. Thoughts formed in fragile minds reach outward across light years of imagination. Like Sagittarius A, we too leave traces that endure beyond our immediate presence. The final fate of Sagittarius A may be to vanish in the silence of Hawking radiation, its mass dissolved into faint whispers of particles. Yet before that day, it will have shaped galaxies, ignited quasars, and perhaps seeded the birth of new universes. It will have lived a cosmic life of destruction and creation, silence and fire. Its meaning lies not only in its end, but in its journey, and in the fact that we, small and temporary as we are, can trace that journey in thought. And so, the enormity of Sagittarius A is not only a scientific fact, it is a meditation on being itself. It reminds us that to exist, even for a moment, is to share in the same universe that contains such wonders. It reminds us that knowledge is not only for solving equations, but for awakening awe. And it reminds us that though we are small, we are capable of asking questions as large as the cosmos. Perhaps this is the greatest gift of Sagittarius A, that in staring into its darkness we find light within ourselves, that in contemplating its silence we discover our own voices of wonder, that in imagining its fate we reflect on our own. Its enormity humbles us, but it also lifts us, showing us that even in the face of infinity, there is meaning in the act of asking, in the act of imagining, and in the act of being alive to wonder at all. In the end, Sagittarius A remains where it has always been, immense, patient, and enduring, hidden at the heart of the Milky Way. It will continue to hold the galaxy together, to shape the dance of stars, and to guard its mysteries behind an event horizon. And as long as we continue to wonder, its story will remain alive in us. A reminder that the universe is vast, mysterious, and filled with horizons that forever call us to look beyond.